In order to support multiple contributors to our blockchain, we need to add a function that checks the validity of incoming chains. As such, let's create a new function in our blockchain class that does the job of validating a chain. If a chain is invalid, the function will return false. Otherwise, the chain is okay and the function returns true. So let's call this function isValidChain. And it has one parameter, an incoming chain. To begin, we'll check that the incoming chain starts with the proper Genesis block. To do so, we'll make sure that the first element of the incoming chain matches our Genesis block. Now, in JavaScript, two different objects that aren't referencing the same original object cannot be equal to each other, even if they have the same exact elements. So to compare the first element of the incoming chain and our Genesis block, what we can do is stringify these objects and then compare their two string versions. So what we're going to have is an if condition that first stringifies the element that is at the beginning of the incoming chain. So if json.stringify and then the argument to the stringify function is the first element of this incoming chain. And we check, well, does that not equal, notice the bang double equals, so bang equals equals. If it doesn't equal the JSON stringified form of the block.genesis function, well, we know that the incoming Genesis block is not valid, so therefore we're going to return false and this chain is not valid. Okay, so we have a condition that returns false if the incoming Genesis block is not valid for this new chain. Next, we run validations on every following block after the Genesis block in the incoming chain. So we're going to have a loop that starts at the position of 1. So for let I equals 1. And we're going to iterate up to the length of the chain and increment I++. So this will go through every block following the Genesis block up to the end of the chain and allow us to run a validation on that block. And we'll create two constants. The first one will be the current block, and we'll set that to const block, and then we'll set it equal to the current block found in the chain by the ith element. So we're going to get chain brackets I, and that'll give us the first one, the second one, third one, etc. Likewise, we'll have our second constant, which is the last block, which we can access with the chain of I minus 1. So if we're at the first position of the block, this last block will be the Genesis block. Moving on, if we're at the second block, the last block will actually be the first block. For our first check with these blocks, the current block's last hash must match the hash of the last block. Therefore, we'll return false if the last hash of this regular block doesn't match the hash of the last block. So we'll say if block.lastHash, if this value is not equal to the hash contained in the last block, well, then we know that the block is invalid, or rather the overall chain is invalid, so let's return false. Now, there's also the possibility that a block's data itself has been tampered with, and its generated hash is incorrect. So in that case, we should check that the current block's hash matches a generated hash for the current block. Right now we have a method that generates a block's hash based on all of its data. Now, it would be convenient if we had a static hash function within the block class that returns a generated hash for the block based purely on the input of the block. Well, let's assume that it exists anyway, because we'll write that function in just a moment. So we'll say, or if the block.hash is not equal to a generated hash, so we're going to say block.blockHash of this block also return false. So we're assuming that a block hash function exists for our block now, and its parameter is a block, and it generates the equivalent hash. Okay, now finally at the end of the function, we want to return true if it passes all of these tests. So we're assuming that this block hash function exists. So let's actually write that within our block.js file. So within block.js, we have a static hash function, but we also want the static block hash function. So let's make our block hash function. As its parameter, we have the one block. And now it's going to be very similar to our hash function, except first we're going to grab all the values we need to generate this hash, which is the timestamp, the last hash, and the data within this block object. And notice the ES6 destructuring syntax, which is declaring a timestamp, a last hash, and a data variable, and assigning it to the same variables within this block object. And now as a result, we have all the data that we need to use this regular hash function. So let's return a call to block.hash, passing in our timestamp, our last hash, and then the data. So in a way, we're wrapping around this regular hash function, and we're providing a convenience for our blockchain class to use to give only the block as regular input in order to generate the hash overall. All right, so that completes our new static block hash function. And overall, if you look back at the blockchain.js file, we now have this new isValidChain method to validate incoming chains. So to ensure that the isValidChain method is working overall, just as we intended, let's test this functionality next.